Okay, hello everyone. We have a half an hour before lunch, so I'm just going to ask for your concentration for a little bit longer, and then we'll break for lunch right after. Good afternoon, my name is Molly Davis. I am the Student Entrepreneurship Lead here at UVM, and today I have the pleasure to tell you a little bit about our Academic Research Commercialization Program and introduce you to our teams. So ARC is the Academic Research Commercialization Program where teams of undergraduate students work with researching faculty to commercialize emergent technologies. When ARC started 4 years ago with startup funds from the Vice President for Research and under the tutelage of UVM Innovations, as well as entrepreneurship faculty, Skylar Bagden and fellow student Sarah Horgan recognized a need from both students and faculty. The students wanted hands-on experience in commercializing new technologies, gaining insight into creating a startup, and learning how to build a business from the ground up. Our professors, who were busy researching, teaching, and forming the minds of the future, needed help with bringing their technologies out of the lab and into our communities. This intersection is where students saw a need they could not only fill, but would gain experience to positively impact our people and planet. We're now in the 4th year of our program here at UVM, and we've seen some incredible success as well as some deep experiential learning. ARC students that have graduated from UVM are now holding positions as CEOs and COOs of local startups like Verde Technologies, ElecGrid, and Burlington Bio. Former student ARC director Nicole Eaton is head of partnerships at Verde Technologies and the head of marketing and communications at VSET Downtown. And another recent graduate, Wasaya Lawton, has joined our team at UVM Innovations as the Interior Northeast I-Corps coordinator. Over the course of this program, we've had over 100 students apply, and we've employed 33 of those students from various colleges across campus. We've accelerated 9 technologies and participated in 10 prestigious accelerator programs across the country, and we are extremely proud of the work that our students are doing and have been conducting over the past 4 years. Today, you're going to be hearing from our 2 current ARC teams. The first, Kaido-crete, led by student Joshua Moore with team members Lila Sargent and Egan Koya. Our Kaido-crete team just came back from the start of the Clean Tech Open Accelerator program in Manhattan. And you'll also be hearing from NeuroCool Technologies, led by Vikyat Mulpuri with team members Rowan Godbout and Ben Spiro. NeuroCool was just accepted into the Interior Northeast I-Corps program that's going to begin next month. After hearing both pitches, you'll have the opportunity to ask questions of our student teams. And if you want to learn more about ARC or have a startup that you'd like to discuss, you can find any one of the ARC students in the lunch breakout rooms or find me in the room after.
Hello.
Good afternoon, everyone. Welcome to NeuroCool Technologies. My name is Vikyat.
I'm Ben.
I'm Rowan. Stroke is the leading cause of disability worldwide, and every 40 seconds, someone here in America has a stroke.
When the brain suffers a stroke, according to the American Heart Association, 2 million neurons die for every minute that the stroke goes untreated. Cooling the brain is the most powerful neuroprotectant that we know to treat this. However, the window of time between the onset of a stroke and when brain cooling takes effect is a key factor in determining how beneficial this treatment actually is for patients. Current methods of cooling, whole body cooling or systemic cooling, involve lowering the entire body into a state of hypothermia in order to cool the brain. This treatment is associated with side effects such as raised blood pressure, altered coagulation, pneumonia, and sepsis. Additionally, in order to receive this treatment, patients need to be sedated, and in order to safely sedate them, they need to be in an ICU. So to get brain cooling to stroke victims, they first need to be reached by EMTs, then transported to a hospital in an ambulance, checked into an ICU, sedated, and then brain cooling can take effect. The mean time that this process takes is 2 hours and 40 minutes, missing a significant chunk of the early critical window where irreversible brain damage can occur. Our team has developed a way to get brain cooling to stroke victims much faster than systemic cooling. It's called selective cooling, and where current methods cool the entire body to cool the brain, we focus just on the area of the neck where the carotid arteries are found. When you feel your pulse in your neck, those are the carotid arteries that you're feeling. They're major arteries that supply 90% of the brain's blood, so by cooling just the area of the neck where these arteries come close to the skin surface, we can effectively cool the brain while leaving the rest of the body alone. And that's really the key here. By leaving the rest of the body alone, patients don't need to be sedated. And because they don't need to be sedated, they don't need to be in an ICU, so we can take this cooling directly to patients, significantly cutting down on the window of time that the stroke goes untreated.
Previously, our team conducted a randomized control trial study using our cold water circulated neck wrap prototype. During this test, water was circulated at 4 degrees Celsius and the wrap itself overlaid the carotid arteries which Ben mentioned, allowing for immediate impact and better chances at a full recovery. The results of this study showed that patients' brains began cooling after just 15 to 20 minutes, and the MRI measured a 0.2 to 0.8 degrees difference in the brain's core temperature, showing our device's efficiency and effectiveness.
We have proof of concept through our randomized controlled trial, and we've applied for a provisional patent. This crucial step demonstrates the feasibility and potential for our technology. Our next step is to apply for non-diluted funding and grants, and once we have this financial support, we can then continue prototyping. Then we can take this prototype and test it in clinical trials, and this data will be essential for further development. Our end goal is a licensing agreement, and this may come at any point in our journey. Here at NeuroCool Technologies, we've decided that the licensing model makes sense for where we're at right now. We've identified some potential partners for development and licensing, and the benefit of partnering with these companies is that it creates an opportunity for us to leverage their existing expertise and industry knowledge. The business model is under evaluation as it may be a single-use device or reusable.
As we progress, we see many applications for our device. Currently, the systemic cooling market's main focus is stroke-based applications, and so we see that as a viable market path and likely where we'll start. However, in the future, we see expansion into possible areas such as traumatic brain injury. Some possible applications include traumatic brain injury, such as sports leagues for concussions, the military for heat exhaustion, as well as general health and wellness. We understand each of these may require different marketing strategies and regulatory considerations. However, we're able to tailor our efforts by highlighting the unique benefits of our device in various sectors. Our team can be thought of as two subgroups, research and commercialization. The research team consists of lead researcher and inventor Adam Sprouse-Bloom, as well as his team of bioengineering assistants. And the commercialization team consists of myself, Vikyat Mulpuri, Rowan Godbout, and Benjamin Spiro. We recently also brought on 2 new bioengineering assistants to help with the prototyping of our device, and our team's excited to share that we've recently been accepted into an I-Corps Business Accelerator program for later this summer. Thank you for your time. We're seeking conversations and advisors with experience prototyping in medtech. You can contact us at the given email or just come have a chat with us later today. Thank you. So now we'd like to open up the space for any questions you guys might have. Sure. So right now we have a provisional patent that expires in 2025. So we're working on further development with that right now. Anyone else? Yes.
How did you get interested in this and like choose, this is what we want to do?
Yeah, so our researcher's actually been working on this technology for a while as he's been in the neurology space. And so it's kind of a technology the ARC program introduced to us. So we partner with researchers and we try to turn that technology into a startup. So that's really how this whole thing got started. Yes.
So while you're testing it, are you testing it on someone who has just had a stroke? Or in other words, I'm just worried if it isn't working, are you losing time that could be in the intensive care unit?
No, and that's something we're hoping to test in our clinical trials later on.
Could you repeat the question?
The first one is if we have a patent, and we have a provisional patent. And then she just asked if we're testing on patients who already have stroke, and we're currently applying for clinical trials through grants to do that testing. Yes.
How does the device actually work? Do you plug it into a wall? Like, is it battery operated? Like, how does it all work to flow the cold water, make it cold, recool it? What does that look like?
Yeah, so we're still in the early development stages, so we're still working on our prototype. So we're not sure how the exact end product will work, but we're also hoping for some variability in prototypes, such as portable devices. So some possible applications could be, you know, one of those camelback backpacks where it has circulating water. One of those maybe for when someone goes hiking or is in the military for heat exhaustion, as well as like an ambulance input is a possibility, as well as on the sports line of a sporting event, the Peltier cooling collar, which is another concept we have in mind, is a fan device, similar to one of those fans you might see a soccer mom wearing.
First of all, well done, and over here. Congratulations, well done. A few questions very quickly. What's your price point, and what margin are you targeting? Secondly, why are you limiting yourself to the medical device FDA route when potentially the recreational use, you just mentioned soccer moms. My 9-year-old was playing lacrosse in 35 Celsius somewhere in Pennsylvania this weekend. They could all use that. We were very worried about their core temperatures. So why not go the recreational route and sell a whole heap of them and then come back to the FDA route, which is more cumbersome, more regulations, and potentially higher consequences if something goes pear-shaped?
So your first question was about the price point. We're still in the prototyping stage and early stages, as we mentioned, so we still need to find out our cost of goods after we finalize our final product. And then once we find that out, we can identify our profit margins to better our pricing. And in terms of the recreational use, we're still open to various, I guess you could say, various possibilities in terms of avenues we could sell this. So we're open to the medical field, like the FDA, as you mentioned, as well as recreational. We're not set on one as of now.
I think this has just been proven to work in stroke, and that's why we started on that avenue. And that's where our researcher kind of wanted to channel his work to.
Yep.
Are you aware of others who are working on something similar in your space? And if not, why are you the first to bring something like this to market?
We have identified some competitors, and they're mostly European companies. The whole body cooling is kind of already what's being done in the US and in medical emergencies right now, but we have not identified anything such as a neck wrap or a cooling device as ours.
Wonderful. Thank you, everyone, for your questions. We'll now invite Kytocrete up to the stage.
You guys did great.
Awesome. Here we go. There's a picture.
Alrighty, good afternoon, everybody, and welcome to Kytocrete, our solution to port infrastructure. Using strong foundations and sustainable practices, we reinforce concrete for a better environment and tomorrow. My name is Egan Koya.
My name is Joshua Moore.
I'm Lila Sargent.
And this is Professor Driver Houston, who is a teacher here at UVM, is the inventor of this technology, and whom we work directly with to further this project.
So I have a pretty long commute into Burlington every day, but I can't complain because I have beautiful views of mountains and animals. But obviously, the most scenic part of my drive are the miles of road work that I have to go through every single time. And this is not a unique experience. If you look at the map, those are all of the active and planned road and bridge construction projects in Vermont just for 2024. Yet the American Society for Civil Engineers has given Vermont's road a grade of C+, which hasn't changed since 2019. So right now it's looking like all work, no reward. Yet Vermont's infrastructure as a whole is actually better than the infrastructure of the US, which has a National Infrastructure Report Card grade of C-, passing, but barely. And it's not just roads. 46,000 bridges in the US are considered structurally deficient, and many dams, levees, and buildings aren't looking too good either. But that's where we come in. Kytocrete are fibers that, when put into concrete, make it last longer, have higher durability, and higher tensile strength. These attributes give it many applications in outdoor infrastructure, bridges, roads, and foundations, which are exposed to weathering elements and abrasion.
Now, as we all know, the construction and concrete industry isn't a great partner with the environment. However, our product directly combats this and mitigates the current epidemic of climate change.
The sustainability of it, the longevity and durability make it last a lot longer and increase the amount of time in between repairs needed, and in turn lessen emissions and preserve our resources.
But a big question is, how do these fibers actually work? So using a special material called chitosan, which is taken from the shells of crustaceans, we can create fibers that shrink in concrete and help close the pores, which prevents things like water and salt getting into concrete. This is especially helpful in places like here in Vermont, where there's a lot of weathering in the winter, and we put a lot of salt on the roads that very much degrade the concrete. Now on the right there, you can see a picture of two samples after being tested in the lab. The sample on the left has a less optimal amount of fiber in it, and you can see that after 168 freeze-thaw cycles, it was not in very good condition. Now, we could also measure this in a different way for how well it lasts. We can see in this chart, we used a scale called the relative dynamic modulus. Now, this is a measure of a failure point in concrete. Our control, which is just regular cement, specifically Portland cement, lasted about 50 freeze-thaw cycles. Now, when we added fiber to the cement with different weight percentages, we can see that it lasted anywhere from 230 to 280 freeze-thaw cycles, which means it will be much more durable in places like here in Vermont. And now, to bring this to market, we have a few methods. We want to either do licensing or B2B. In a licensing situation, we'd like to license the technology to a construction sector or chemical company. Now, with multiple license deals, we believe we could achieve around a $5 million serviceable obtainable market. If we were to do selling directly to concrete manufacturers, we believe we could achieve a $23.3 million serviceable obtainable market, and that's a relatively conservative estimate.
Now, as Josh previously mentioned, we plan on coming to market through a licensing deal with a large construction sector chemical company. And we plan to start our business journey there because we can leverage the already existing assets of some of these large corporations, namely their networks and supply chains. We'll make money through licensing fees, royalties, as well as milestone fees. And second in our itinerary will be selling business to business, as selling business to business and manufacturing our own product will require a very large initial capital expenditure that we do not currently have, but licensing will allow us to scale our business up and succeed at helping our people and our planet.
So what are we doing right now? We are currently conducting customer discovery as well as participating in the Cleantech Open Northeast Business Accelerator Program, which will give us the resources we need in order to find partnership opportunities for the future. Then, in the winter, we hope to obtain funding, either through a research deal or grants, which will allow us to refine our process, get building certifications, establish a supply chain, and create proof of concept. Then, once we have fully refined chitocrete, we will license it to our partner and continue to grow.
Thank you so much for listening to us today. Really what we're looking for right now is we want to talk to everybody out there who might have experience in the concrete industry or fiber reinforcement industry, so we can help offset our inexperience at the moment. Thank you so much for listening. I'd love to open the floor to any questions.
Thank you for your presentation. I have a couple of sort of questions and comments. Number one is about the fiber itself that goes into chitocrete. Mm-hmm. How do you get it? You know, what kind of process are the animals? Do they have to be sort of eliminated? You know, what's that about? The other thing is the competitive challenge about this. If you create a concrete that lasts twice as long as concrete today, then you are creating a problem for traditional concrete producers, because you're reducing their market by, 50%. Mm-hmm. In the past, this is a long time ago, somebody figured out how to turn tires into a replacement for asphalt. Right. That, you may know about that, it sounds like you know about that. That patent was acquired and squashed, like catch and kill is what they call it, I think, today. So what are your thoughts about that? Thank you very much.
So why don't we start with how the chitosan is actually sourced. So crustaceans is where it's from, and crustacean shells are often just a discarded waste product in the industrial fishing industry. And so we can take that waste product and turn it into these fibers. So it ends up being a very sustainable material. And as for kind of taking away that market share of these large competitors, this would be more marketed as a premium product. We want it to be more readily available, but it's going to be more expensive in every single case we can do. So a premium product, but it can help that sustainability still. Any other questions? Awesome.
Thank you. I'll turn it around and ask the question, being an organic source, the compound, the chitosan, it is probably vulnerable to microbial degradation. Might that be a challenge to allow the concrete to degrade quicker?
I'm not sure on how the concrete will degrade quicker. That's a great question for a researcher who I can connect you with. We're still in a lot of lab testing, so we have a long ways to go, and that's why part of our timeline is creating a research deal so we can study the concrete more efficiently and get a better understanding of how it functions. But I'd love to connect you with our researcher about that. Yeah. Any other questions? Yeah.
I'm curious what challenges to scalability you identified.
I'm curious what challenges to scalability you have identified.
Definitely. So one of the main things at the start is the need of capital, and a lot of it, to actually manufacture and produce something of this scale. So that's why we were going to start with licensing, so that we wouldn't have to get a bunch of funding from investors. If you want to.
Yeah. So that initial capital investment is very important, and that's why we want to license it to such a large chemicals company, because they would have the networks needed, and they would also have the initial capital needed that they could put into a project like this. Other than the capital and the need to make these manufacturing facilities, the next biggest challenge would be the supply chain, specifically with chitosan, but there's a lot of the supply chain to make this material already. We just need to create the factories to create the final fibers. So those would probably be the biggest challenges.
Fantastic. Thank you, everyone, for your questions. Oh, do we have one more over here?
Yeah.
What is the technology and processing to convert crustaceans into your fibers?
Right, so when we get the crustacean shells, you can take chitin out of them and transform it into chitosan, and once we have this chitosan, we take distilled water and acetic acid, and we kind of make it into a mixture and boil the distilled water and acetic acid out of it, which creates these sheets of chitosan fibers that we then can cut up and place into the concrete.
How is the waste material, the discharge from waste material process?
The only waste materials are the acetic acid and the distilled water, but it's not really a waste material. It evaporates into the atmosphere and doesn't really become much of a problem.
Perfect. Thank you. One more round of applause for our ARC teams.
Thank you so much.
All right, everyone, you have made it to lunch. So I just want to remind you about the 2 breakout sessions during the lunch and learn times from 1 to 1:45. They'll both be held in the Levac ballrooms. The first will be Doug Merrill, our Regional Innovation Officer with the Vegan Tech Hub, and the other will be with Tino from the Vermont Professionals of Color Network, and that will be in the Mildred Levac ballroom. We'd also like to thank our lunch sponsor, Sodexo. So if you have a meal ticket, you can pick that up right on the outside of this room. If you've brought your lunch, please feel free to join us back in here to mingle and have our lunch, and we'll begin again at 2 o'clock. Thanks so much.